Hi, ladies and gents. Let's talk about some of the important acids that you need to know about or have heard about, because these are the chemical rock stars of the acid world. So, we're going to begin with sulfuric acid. Sulfuric acid is always one of the top one, two, or three chemicals in the US every year, meaning that it is used the most. What is sulfuric acid? Well, its chemical formula is H2SO4, and that is hydrogen sulfate, but it is an acid, and so it has a different name, and that is sulfuric acid. It is commonly used as battery acid in lead acid storage batteries that are used in vehicles. And it is such an important acid because of the fact that it is an industrial chemical. Now, there's the reason I have the picture of this nice fella holding a very large wrench. Yeah, it's a cool tool, but you don't own the cool tool just to own the cool tool, not unless you just want one. You own it because you can do nifty things with a wrench that big. Well, the same thing with sulfuric acid. It is such an important industrial chemical because it is so strong that it allows chemists to do things they could not do with other chemicals. So think of these strong acids and strong bases when we get to them sort of as a big wrench. It is a huge monster tool. If you're a cook, it's your favorite knife in the drawer. If you're a woodworker, it's your favorite saw. If you are a sewer, it's your favorite pair of scissors. It is something that is used over and over and over that allows the chemist to do amazing things with it. So what is sulfuric acid used to make? Well, here is a lovely little graph that I found that gives you kind of an indication of all of the places it's used. About 15% of all the sulfuric acid used in the country is used to make detergents. So that's everything from your laundry soap to your dishwashing liquid. About 11% goes into paints and pigments. This is to paint your home and to paint everything from commercial things like bridges and buildings, but also pigments that dye your clothing and dye everything from furniture, patio furniture, and plastics, and anything that's out there in the world that's colorful may have gotten its color pigmentation at some place in its chemical life, may have been exposed to sulfuric acid. Fibers, rayon, paper, plastic, polyester, Dacron, all of the wonderful synthetic fibers we use, many of them have been exposed to sulfuric acid in their production. Plastics, all of those lovely plastics that we are recycling and sorting to create those plastics, again, big chemical wrench that allows chemists to make these designer molecules. Other uses, everything from pesticides, explosives, making batteries that power your cell phone, to your flashlight, to your wireless mouse. Amazing things like that. And then about a third of all of the sulfuric acid used out there goes into fertilizer. And you might go, I don't care about fertilizer. Well, you care about food, don't you? And you like eating. The population of the planet is approaching 8 billion people, and we got to feed them somehow. And that means we have to have productive ground. Well, if we need productive soil, we have to fertilize that soil. And that means sulfuric acid. And that's where the sulfate part of ammonium sulfate, a very, very useful and important fertilizer, comes from. So sulfuric acid on its own, it's sort of like as I mentioned, a big tool, but it can be used for so many other things. Another really important acid out there is hydrochloric acid, HCl. This is stomach acid. You are carrying around a little jiggly bunch of it right now in your tummy. And you might wonder, how can your body handle that? Well, your stomach is lined with a mucous membrane that contains some bicarbonate ions that help protect it, because you are containing this little bag of hydrochloric acid right now that can do you damage. But that mucous membrane that lines that stomach helps protect it so it doesn't digest itself, which is pretty amazing. When these bicarbonate ions react, with the stomach acid, they produce a little CO2 gas. Now, what does the CO2 gas do? Well, you may have in your life produced a burp. And those burps are those carbon dioxide bubbles, and they have to go somewhere. So out they come. That is a natural byproduct of that acid-base reaction. Small quantities of chlorine, but it's mostly carbon dioxide that you are expelling when you burp. Once in a while, there is an out of control situation with the hydrochloric acid. And if it penetrates that lining, it can produce an ulcer. And some ulcers are actually produced by bacteria, not by other means. Hydrochloric acid has another name, and that is muriatic acid. If you go down to the local hardware store and ask them for some hydrochloric acid, they might look at you funny. But if you walk into the hardware store and say, I want some muriatic acid, that's not going to be a big deal at all. And the reason is because the muriatic acid is commonly used to clean concrete. If you have a concrete driveway or a concrete patio or garage floor and it has oil and grease and debris on it, you want to clean it just because it's mucky, or prior to painting, you can smear the muriatic acid all over it, let it sit for a few minutes, and then power wash it away with lots and lots and lots of, dilute it down with a lot of water. And I have done this on our garage floor before we repainted it. And it bubbles up. You get a lovely collection of hydrogen gas bubbles that are produced, and make sure you're doing it in a well-ventilated area. But you can get this at your local hardware store. Some batteries actually do contain hydrochloric acid, and in the production of Jell-O and some sugars. Again, food production actually can use hydrochloric acid. Again, this is a strong acid. It's a big chemical wrench, useful for making chemical reactions occur. The third big acid out there that is used for lots of things is nitric acid, HNO3. Nitric acid contains a nitro group. These NOs, the NO2s, the NO3s, these nitro groups are amazing, and they store lots and lots and lots of chemical energy. Well, nitric acid is commonly known to produce yellow-brown stains on things. There's a small quantity of nitric acid that gets emitted when someone smokes cigarettes. So if you or someone you know is a smoker and they have like yellow-brownish stains around their fingertips, that is very often a small quantity of nitric acid staining. Nitric acid has this kind of yellow browny color to it. When we were talking about air pollution and that nitrous oxide smog that you get, that again is due to that yellow brown coloring of these nitrous oxide gases. The big thing that nitric acid is used to produce is fertilizer. Remember, fertilizer, we got to feed the planet, we got to feed all the people. That means we have to have productive soil, productive agriculture. We have to have those nitro molecules. Now, this also can be used as an explosive because of the fact that it contains nitros and nitro groups, lots of stored energy. TNT, nitrotoluene. Toluene is this shape in chemistry. You throw 3 nitros on it, you have trinitrotoluene, commonly known as TNT. Nitroglycerin. Glycerin is the same sort of product. You can actually buy glycerin at the drugstore. And it is used in a lot of hand creams and lotions and things like that. Well, if you take that glycerin and you throw some nitros on it, you make an explosive product, nitroglycerin. Again, big chemical wrench. You can do a lot of amazing chemistry with these things. We're now getting into some acids that are important, but they are not as strong. They're not as full of chemical energy. One that you're going to periodically encounter is phosphoric acid. Phosphoric acid The colas Coca-Cola is notorious for being a chemical or a compound that you drink that actually contains some phosphoric acid. Not a lot of it, but a little bit. Gives it a slightly different flavor than some of the other pops that are out there. Phosphoric acid can be purchased as a cleaner. It is a good degreaser and things like that. Not so much a degreaser, but it is good for etching areas before you want to clean. So grout and removing rust and hard water and things like that before you want to repaint or resurface. Some weak acids that you have encountered are going to hear about. One of my favorites is carbonic acid. Carbonic acid is nothing more than water and carbon dioxide. Now, a certain amount of carbonic acid gets produced just by rainwater coming down through the atmosphere full of carbon dioxide. And so carbonic acid gets produced naturally. This naturally occurring carbonic acid does a couple really interesting things. It will eat through rocks and subsoil, producing a lot of underground cave-like structures. It will cause some real interesting geology as it eats through weaker rock and stronger rock is left behind. As the CO2 levels in our atmosphere rise, the carbonic acid levels in the oceans rise. And the challenge with that is a lot of sea creatures are made of limestone, and these limestone sea creatures can be dissolved by acidic oceans. So the acidity of the ocean is rising, and it puts coral reefs and other things in danger. One of the most tasty ways of experiencing carbonic acid is soda pop. If you go to a fast food restaurant, there is usually a soda fountain dispensing gizmo, and down below they have the syrup and they have big containers of CO2. And then they have a line that contains water. And those three things are mixed. At the moment you want your fountain drink, all three of those are mixed at that moment, and that's how the carbonic acid gets mixed. The CO2 gets mixed with the water and the Coca-Cola or Mountain Dew syrup right then. So it's pretty nifty. Another common weak acid is vinegar, known as acetic acid. Acetic acid has been used for preserving food for over 4,000 years. It produces this really, really highly acidic environment. Bacteria and mold can't live in that environment. Because it can't live in that environment, it is a great way to preserve food. Humans discovered this sort of by accident, and we actually also like the taste. So we pickle everything from eggs to cucumbers. Lactic acid is in milk. In low quantities, we have lactic acid in milk, but it also builds up in your muscles when you exercise in a low oxygen environment, and you get my mom used to always call it getting a stitch in your muscles and it hurts. Well, that is due to the fact that you get this buildup of lactic acid, and when you have a cool down period after exercise, you are trying to work that lactic acid out of your muscles, because if you let it accumulate, it will increase your chance of soreness. You want that lactic acid to have a chance to metabolize away and out of those muscles. Two other common weak acids. One is citric acid. Citric acids are common in citrus fruits, lemon, limes, grapefruit, things like that. This citric acid is used in all sorts of things. One, it helps disinfect and deodorize. It removes hard water stains. Some dishwashing additives for automatic dishwashers are nothing more than citric acid. And it removes hard water stain, which are nothing but magnesium and calcium. So it reacts with those group 2 metals and helps get rid of those hard water stains. It also is in alpha hydroxy skincare products that is used to help smooth skin. And one of my favorite weak acids is acetylsalicylic acid, which is aspirin. Aspirin is a naturally occurring acid found in aspen trees. And this has been a pain reliever used for thousands of years. All right, folks, that'll do. We'll see you later. Bye-bye.